What are different types of scattering? What is Rayleigh scattering? And what is the Rayleigh scattering law? Say, the scattering is what? Whenever it finds an obstacle, if that obstacle is of the order of the wavelength of the light, the scattering will happen. It can be gas molecule, it can be dust, it can be water vapor. So scattering of light is that phenomena in which this light gets deviated from its straight path on striking an obstacle, and these are the obstacle: dust, gas, water vapor. Actually it will go in the random direction. So the Tyndall effect and the evenings and the afternoons of sun, this all happens because of this scattering of light. So we have different types of scattering. Let us say the energy of incoming light is E, and when it gets scattered away, the outcoming photon, the energy is say E1. Okay, this spreading of wave ray, or you can say this deviation. Now if E and E1 are same, then we call it as elastic scattering. If E and E1 are different, E1 is less than E, that is the energy after this scattering is less than the initial photon, that is called as the inelastic scattering. So here you see different kind of scattering. So the inelastic scattering are of mainly three types: the Rayleigh or Mie and electromagnetic scattering. There are others also like Raman and etc., but these are the main. So the Rayleigh is also called as selective scattering. So when it comes to the Rayleigh's scattering law, this is very important law because it is concerning to all the kind of scattering. It says the amount of scattering of light is inversely proportional to the fourth power of its wavelength. That is, if I am writing it as intensity of scattering, then it will be inversely proportional to the lambda to the power 4. Lambda is the wavelength. So let us say we are talking about a white light. Now white light, the sunlight coming from the sun. Now we have Vibgyor. So now you see the wavelength, highest wavelength is of red light, lowest frequency. So the highest wavelength, the low will be the scattering. That is why red light scatter less. And the blue, violet, this indigo, mostly we are talking about blue, the lambda is less. That is, the frequency is higher. That is why this, because lambda is less, it will be inversely proportional to intensity of scattering. So it will be scattered more because they are inverse relationship. So shorter wavelength colors are scattered more than the longer wavelength colors. So whenever the sun is just above our head, when the sunlight is coming, the observer is there, most of the blue and other light below it, they get scattered. And when they scatter, you only see these light, means you see the atmosphere as blue just because they are scattered more. The red light gets passed, so you see sun as red. Okay. Now when it comes to the evening and the morning time, what happened? Because the distance is away from the user or the observer, the blue lights get scattered away from us. It goes up, means it goes scattered on the other direction. So you only see the red, hot and orangish kind of sun when it is at horizon. So this is how the scattering effect makes different scenario like Tyndall effect, etc. So model of light, the scattering can be divided into three domains, and this is based on a very dimensionless. There is no dimensionless. There is no dimension, actually size parameter. We call it as alpha. Alpha is nothing but the circumference divided by the lambda. Only the circumference, because mostly the particles in the earth, so like the water particle, will be round shape. We assume it to be round shape. So pi into dp, this is nothing but the circumference of a particle. Lambda, this is the wavelength of the incident light of the medium. So based on this alpha, we have three domains. So we can divide this scattering type. See, if alpha is less than equal to 1, when you will get alpha less than equal to 1, this will be Rayleigh scattering. when the wavelength of light and this particle, the particle is smaller than the wavelength of light. The wavelength of the light, the particle is smaller than that. When alpha is equal to 1, what does it mean? It is Mie scattering, MIE. That is, the particle and the incident ray, they have the same wavelength. The wavelength will be same. The Rayleigh scattering, the particle will be lesser in size than the wavelength of light. Finally, we have the electromagnetic scattering or geometric scattering, and this happens when alpha is greater than or equal to 1, when the particle is much larger than the wavelength of light. This is called geometric scattering or electromagnetic scattering. Alpha is greater than or quite greater than 1. So this alpha decides what is the kind of scattering, Rayleigh, Mie or geometric scattering.